experiment, volunteers were made to sit in freezing water for 30 minutes and later forced to wear wet clothes for hours. It was the perfect setup to catch a cold, but they caught no more colds than the other group, who stayed warm and comfortable. Years later, another team tried something even more strange. They asked infected volunteers to kiss healthy volunteers for at least 1 minute. 16 healthy people were kissed by those carrying the virus, and only one got infected. For a disease that spreads like a wildfire, it made no sense. We humans barely know about a disease that has infected everyone in the world for thousands of years. In 2000, a drug called pleconazole was created that could finally kill the virus. At first, it worked, and we felt that we have conquered the common cold. But within few days, the virus mutated and became resistant. Years of research beaten in just a few days.
Every other medicine the doctors prescribe you only does one thing. It makes you feel better by suppressing useful mechanisms like fever and runny nose not affecting the virus at all. Over-the-counter pills to lower the temperature, steam to open your nose, warm water to soothe your throat, and a Netflix subscription to lie in bed. But there is yet no effective drug that can kill the virus. In fact, these over-the-counter medicines are found to give similar results to placebo drugs. At this point, we can clone animals, we can reach the moon, but can't reduce the duration of a common cold infection. You might wonder, why spend years curing something that seems harmless and fades away within a week? Every time a person gets infected, they have to miss days from work or school. And don't get me started on how uncomfortable it gets. The US economy loses nearly $25 to $40 billion every year simply because people can't show up to work with a cold. It's become so frequent that we've simply accepted it as a part of life. We can end this widespread disease by creating a vaccine. Easy, right? Well, here's where the story takes a big turn. Because the truth about the common cold is far stranger than you think. There isn't just one virus behind the common cold, but many of them. In fact, hundreds of them. There are over 250 virus strains that cause this disease. Common cold is an umbrella of diseases caused by these viruses. Many species like rhinovirus, with single-handedly over 160 different serotypes, adenovirus, influenza virus, all of them cause common cold. Rhinovirus, among all of them, are responsible for majority of common cold infections. That means we can significantly control the common cold if we just take down the rhinovirus. Now we knew our target. The goal was simple: build a vaccine powerful enough to end it once and for all. But mixing together over 100 different strains of rhinovirus was impossible. So in the 1960s, researchers tried mixing up antigen to only 10 serotypes in one single vaccine. And this idea failed miserably, as people still got colds.
Finally, after a few decades, Dr. Johnston and Dr. Ullman came up with an idea. They studied genetic sequence of over 160 serotypes. They noticed something strange. A small protein on the virus's shell that was almost identical across many strains. What if they make a vaccine which targets that common protein? They took that piece from rhinovirus 16 and injected it into a mouse. Vaccinated mouse was then tested for 3 distinct serotypes. Results? For the first time in human history, it worked. We felt like, finally, we have made it. But just when things were about to move forward, a disaster struck. The company funding the project changed its leadership, and with it, changed their priorities. The scientists leading this project retired. After years of work, the vaccine that could have ended the common cold was put down. But the best thing about Homo sapiens is that they never give up. Across the Atlantic, another scientist was quietly working on the same problem. During a family vacation in Florida, his young son got sick, and while everyone else went to the beach, Dr. Moore was stuck in the hotel room. And even though he was a pediatrician, he felt helpless against a tiny, incurable virus. That's when he made a decision he would find a cure for the common cold. Moore revisited all the vaccine experiments from the 1960s and 70s. Back then, scientists had actually managed to create vaccines that worked, but only against a single strain or very few strains combined. But now, times had changed. It was possible to mix multiple strains in one vaccine. For his first trial, he combined 50 strains of rhinovirus into a single vaccine, then tested it on rhesus monkeys. The results were unbelievable. Monkeys were protected against nearly every virus strain, and for the first time in decades, humanity was on the verge of defeating the common cold. Only a few pharmaceutical giants in the world have the power to make vaccines, and even for them, it's barely worth it. Vaccines take up less than 5% of the global drug market because they're expensive, slow, and brutally uncertain. When a company sets out to create a new vaccine, they'll need at least 10 to 15 years of research and $1 billion of costs. And even after all that, most of them still fail in clinical trials. There's a lot of risk involved. Even if you manage to make a working vaccine, you still face the costs of mass production, storage, transport, regulations, and approvals across dozens of countries. Every step is another mountain of money. Even after successfully passing all the clinical trials, each vaccine antigen must be produced, purified, and validated under strict conditions. For a vaccine with hundreds of different viruses, that requires unmatched precision. For comparison, the largest multivalent vaccine we have today, the pneumococcal vaccine, covers just 23 strains. These all conditions might make the vaccine very expensive. Other problem is people. People won't bother to buy an expensive vaccine for a disease they have accepted to live with. People will empty their wallets when they're sick, but almost nothing to stay healthy. Even after all these hurdles, if we still end up making a perfect vaccine, the virus will simply mutate. Rhinovirus has a primitive flaw, the flaw that turns into its superpower. Their polymerase, the enzyme that copies their RNA, is terrible at its job. It makes tons of mistakes while replicating, and because the virus multiplies and spreads so fast, it can run thousands of genetic trial and errors in just a single day, until it finds the perfect version to survive. A perfect virus isn't the one that kills the host. It's the one that learns to live with it. The one that spreads quickly and adapts faster than we can react. And that's what makes the rhinovirus almost perfect. Maybe we will never be able to defeat this small primitive virus. Maybe it just needs to stay a quiet reminder that nature always wins. A reminder that nature is still the biggest force on the planet.